This past summer, on my way home from an astronomy trip to Northern California, I passed through Reno, Nevada, home to the Battleborn Battery factory. Now, Battleborn is a US-based company, and they design, build, and test all of their batteries in their factory right there in Reno, Nevada. I had read about them ahead of time and called them in advance, and they were kind enough to give me a factory tour when I stopped in Reno on my way home. I'll put a link below to a factory tour video recorded previously by Will Prowse, and that way you can see pretty much what I saw. Having spent 40 years in the high-tech industry myself, I can tell you I was very impressed. So when I got home, I gave them a call and asked if they wouldn't mind sending me one of their 100 amp hour batteries so that I could test it out for use for amateur astronomers and write a review. And they were kind enough to send me this battery to do that. Now, other than that, I received no other compensation from Battleborn and no input to my reviews of their product. So let's talk about this particular 100 amp hour battery from Battleborn. The first thing to note that at $799, this battery is at least twice as expensive as some of the Chinese batteries from overseas. Now, what justifies that? Well, first of all, you can easily pick up the phone if you need technical support or you have a warranty issue. And like me, if you give them advance notice, you can stop by the factory and get a tour if you're traveling through Reno. Another major difference between the Battleborn batteries and the cheaper batteries that you find out of China is that the Battleborn batteries use cylindrical cells, whereas these other batteries use prismatic cells. Now, I won't get into all the technical differences between cylindrical and prismatic cells, but cylindrical cells have several advantages over the prismatic cells. First of all, they dissipate heat better than prismatic cells. Also, the design lends themselves to automated manufacturing, which provides higher yields and ultimately better reliability in the individual cell components. Another critical difference between a battery built with cylindrical cells and one with prismatic cells is it takes 120 cylindrical cells to make up this 100 amp hour battery from Battleborn. I'll even provide a link below to a teardown video that shows you what you can see inside this battery. In contrast, these prismatic cell batteries use 4 individual prismatic cells to give you the 12.8 volts at 100 amp hours. Now, if one of those prismatic cells goes bad, the battery is no longer useful. On the other hand, if 1 or 2 cylindrical cells in this battery go bad, you probably wouldn't even notice. Another major difference between the Battleborn battery factory and these Chinese batteries, Battleborn has a 10-year warranty, whereas the others provide 2 to 5 year warranties. Now, let's review some of the particulars of this 100 amp hour battery. This battery weighs 31 pounds, which is half the weight of a typical 100 amp hour lead acid battery. It's just under 12.8 inches long by 6.86 inches deep and just under 9 inches tall. Now, I've added my own cables here to hook up to my astronomy equipment. It comes with pretty solid lugs at the top, and I've bolted these on. And I have Anderson power pole connector on the end of my cables, but you can attach your wires whichever way you like. Battleborn specs their batteries at 3,000 to 5,000 full discharge cycles. So that means you can run this from full capacity down to 0 capacity 3,000 to 5,000 times without damaging the battery. They also spec this at a 10 to 15 year lifetime. Now, like all lithium iron phosphate batteries on the market, this has a battery management system inside. The purpose of the battery management system is to make sure that the individual cells in here are well balanced, so no one gets drained faster than the others, and they maintain basically the same voltage across all of the cells. It's also there to prevent against things like short circuits, high voltage, and low voltage. That low voltage protection really means that the BMS will shut the battery down when the voltage on the individual lithium cells inside reaches the point where any further discharge would cause damage to the cell. So the BMS is protecting this so that you get your full 3,000 to 5,000 full discharge cycles. Also, the BMS will protect against high temperature and low temperature situations. So this battery can be discharged at a temperature of -4 degrees Fahrenheit to 135 degrees Fahrenheit. That's -20 to +57 degrees C. On the other hand, you cannot charge this below 25 degrees Fahrenheit. You can discharge it down to -4, but you can't charge it below 25 degrees Fahrenheit. And you can charge it up to 135 degrees Fahrenheit. So that gives you some background on the company and some basic statistics on the battery itself. In the next sections of this video, I will do a full discharge test on this battery to find out what the actual capacity is, and more importantly, at what capacity the voltage drops below 12 volts. I will also do charging tests using an AC charger and also doing a charging test using solar panels. And last but most important, I will share with you my experience with this in the field, powering my astronomy equipment. I'll let you know how long this was able to last powering my setup. And given the power requirements of my equipment, you can scale that and determine how long this 100 amp hour battery would last for your equipment out in the field. The first test I'm going to do here is a capacity test where I'll measure the full discharge capacity of the Battleborn 100 amp hour battery. I've fully charged this battery first, and I'm going to use this dummy load I typically use, which has a cooling fan to keep the load cool. And I've added these Anderson power pole connectors to the terminals of the battery to make it easy to hook up the dummy load. Now if we turn this on, I'm going to run this at about 5 amps. 5 amps is around 65, 66 watts. This is a load that is pretty reasonable for astronomy equipment. Most setups would be at or below 60, 65 watts. Some will be higher, and I've run this test as high as 9 amps, which is a pretty high load for an astronomy setup. And there's really no difference in the capacity that you will measure whether you're doing 5 amps or 9 amps or 3 amps. This battery is rated at 100 amps, so 5 to 10 amps is no sweat or strain for this battery. So this is going to take quite a while. Given 5 amps and 100 amp hours, we expect it to take about 20 hours. So let's let it do its thing, and we'll come back when it's finished. Okay, so now the battery is fully discharged. It took 21 hours and 33 minutes, and we measured 109.33 amp hours, which might be surprising given that this is rated as a 100 amp hour battery. This is no mistake. First of all, I typically do the discharge test multiple times, and in the case of this battery, I've done it. This is the 4th time I've done it. And I've measured anywhere between this 109.3 and 110.8 amp hours. Now, why would that be? And that's simply because when Battleborn puts together the cells inside their batteries, they measure the individual cell capacities, and they arrange their batteries so that they will have somewhere between 104 and 108 amp hours of capacity. That way they overbuild to make sure that the customer is getting 100 amp hours. So the other thing to note is not just how many amp hours, but how many amp hours where the voltage is maintained above 12 volts. As most people know, lithium-ion batteries do a better job of maintaining their voltage during discharge compared to lead-acid batteries. So I've collected that data as well, and we can take a look at that now. So here's a plot of the data showing the voltage versus percentage battery capacity. The orange curve is the data I collected for the Battleborn battery, and the purple curve is a typical lead-acid battery. So for lead-acid batteries, you see the voltage starts to dip below 12 volts when you're at about 42% of the battery capacity remaining. Whereas for the Battleborn battery, it remains well above 12 volts and only dips below 12 volts when you reach about 5% capacity remaining. So for about 95% of the usable capacity of the Battleborn battery, you have more than 12 volts. So that's much, much better, almost twice the 12 volt and above capacity for a typical lead-acid battery. So we have a couple of options to recharge our battery, and the first involves using an AC charger. Now here we have an AC charger specifically designed for lithium batteries, which is what you want to use. It will supply the correct voltages and the correct charge profile to make sure you fully charge or fully recharge your battery. This is the 10 amp version. They come in higher current capacities. And as I said, this battery can take 100 amps, so you can easily use a 20 or even a 30 amp charger without any concern. So to recharge, we'll plug the output of the charger to the input of the battery, and then we'll connect the battery charger to the house power. And as you can hear, the fan comes on, the cooling fan for this charger. Now the charger will continue to pump current into the battery until it's fully charged at 10 amps. And considering that we found the capacity of this battery was around 110 amp hours, this should take about 11 hours, somewhere around 11 hours to fully recharge. And when it's fully recharged, the charger will shut itself off, and so you don't have to be present at that point in time. So let's just let it do its thing, and we'll come back when it's finished. All right, so the charger has shut itself off, and it's taken right around 11 hours, kind of what we expected. Just a little over 11 hours, so I suspect at the end the current dropped down a little bit, and there was a little bit slower charging at the end. So if you want to charge this battery faster, you could get something like a 20 amp charger and charge it in half the time, about 5.5 hours. So for the solar charge time test for this 100 amp hour Battleborn battery, I'm going to use two 100 watt solar panels from Jackery, because otherwise it'll take quite long. Even with these two 100 watt solar panels, it'll still take quite a while if I were to have to recharge this from 0% state of charge to 100%, which may not actually be the case out in the field. It's very unlikely you'll have to fully recharge in the field. But I will do the recharge tests from 0% to 100%, and I'll do it multiple times so we can get an average. Now, I do have these this cable with the Anderson power pole connectors on this end, and the Jackery comes with 8mm plug, and you'll find that lots of other solar panels come with MC4 connectors. So you'll have to get the appropriate adapters. Also in this case, I have two inputs, and so Jackery has a Y connector. So I can connect each solar panel 8mm input into the Y connector, and very fortuitously it has a Anderson power pole connector output. In addition to the solar panels and the connectors, we need a solar charge controller. This one here is from Bioino Power. It's a 30 amp solar charge controller. You can get them online. I'll put links to some of these things. You'll have to make your own cables with the appropriate connectors for the battery input and for the solar panel input. Also, you'll want to make sure that the solar charge controller has a lithium battery setting. You'll want to set it up according to the specifications of the manufacturer. Most of them are pretty much the same. 14.2 to 14.6 volts is the charging voltage, and so on. The other thing to know is that you want to connect the battery first and then the solar panel second. So in this case, we will just plug in the battery, which supplies power to the solar charge controller. Then you can program it, and then the output from the solar panels, put that in there, and then we'll begin to see current accumulating on the solar charge controller. And in actual real case, you don't want the battery sitting in the sun. So I typically tuck it behind one of the solar panels. And also, to minimize the time, I'll rotate the panels every so often to keep them as square onto the sun as possible. Jackery solar panels come with 8mm connectors on the end. And not only that, I have 2 of these. So I have to use a Y combiner from Jackery, and that takes the 8mm plugs on the input side, and it has Anderson power pole connector on the output side. Now, other solar panels, typically you'll find MC4 connectors, so you're going to have to scrounge up the right connectors for your solar charging. And for this test, I'm using a 30 amp solar charge controller from Bioano Power. I've had to make the input wires and connectors myself. Again, I like to use Anderson power pole connectors, but you can use whatever you like. The other thing you need to know is make sure that your solar charge controller has a lithium battery charge setting. Typically, it requires a voltage between 14.2 and 14.6 for the charge voltage. Once you power this up, as you connect it to the battery, you'll be able to adjust the settings specific for a lithium battery according to the specifications of your battery manufacturer. The other thing is you want to connect the battery first, and then you want to connect the output of the solar panels to the input of the solar charge controller. Then you will begin, as you go through this menu on this screen, you'll begin to see the charging current and the charging voltage. And another thing is, you would typically not want the battery to sit in the sun. So what I do is I tuck it behind one of these solar panels so that it doesn't get hot while it's charging. And then with these 2 solar panels in bright sunlight, I'll typically get between 5 and 5.5 amps. So combined, that would be 10 to 11 amps. So you should expect this thing to take roughly 10 hours to fully charge from 0 state of charge to 100%. I'm here at the CalStar Star Party, which is held in South Central California at Lake San Antonio. I'm here for 4 nights, and I brought with me one of these Battleborn 100 amp hour lithium iron phosphate batteries to see how easy it is to use and how long it will last with my setup. In this case, I've been running it several nights without recharging during the day. Of course, I can recharge during the day, but I want to find out how long this thing will last in case I was in a situation that I couldn't recharge during the day, or maybe somebody doesn't want to invest in the solar panels and solar charge controller. They can find out how long this would last for them, and they can take it home and recharge with a simple AC charger. And I'm running this rig. Let me explain what I have here. Obviously, I have a software BISC Mighty mount. I'm powering the Mighty mount, which itself then supplies power to my ZWO ASI 1600 color camera. It's uncooled, so it doesn't require extra power for cooling. It's also powering my guider from ZWO, my Celestron focuser. And I have through the mount power for a dew strap, and I'm running that at 50% power. Now down below, I have a Pegasus power box, which is my power distribution hub. I have a mini PC, which is running the SkyX and controlling the mount and cameras and the imaging process. I have a GLI Link mini portable router, and I link to that with my Dell 15.4-inch laptop. So the mini PC does the heavy lifting, while my laptop is used fundamentally as a monitor to see what's going on, check in on things. And the laptop is powered by AC, so I have an AC inverter here connected to the Battleborn as well. All told, I'm running about 63 watts, 43 watts DC and 20 watts AC. And the first 2 nights was a total over 12 hours, and I've used 57% of the capacity of the Battleborn. Last night was a bust. As you can tell, it's a little windy today. It's supposed to get better this evening. It was very windy last night, so didn't do any imaging then, but I should have enough juice left to run about 9 hours tonight without recharging. So let me zoom in on the equipment down below so you can get a better image of what we have there. All right, so here's a little close-up of how everything is assembled. I have 2 sets of cables coming off the Battleborn, cables that I made myself, and I use Anderson power pole connectors on this end because I like Anderson power pole connectors wherever I can do that. So this cable is connected to the Pegasus power box. It's the input power to the power box. From there, power is distributed to my mini PC, to the dew heater, and over to this DC to DC voltage converter. So this converts the 12 volts from the Battleborn into 48 volts, which is what the software BIS mounts need. And then I also have the mini PC is supplying the power to the GLI net mini router. I have a separate cable coming off of here for AC, and that goes to my AC inverter, and then I plug in my cable from my laptop. And I put an inline watt meter here so I could keep track of the power being consumed AC. The Pegasus power box has an internal watt meter, power meter. It'll tell you how many watts you're using, what the voltage and current draw are, and it'll tell you the number of watt hours and amp hours. So I can keep track of the DC power consumed or energy consumed, and with this I can keep track of the AC energy consumed. And as I said, over 2 nights, a little over 12 hours, I used 57% of the capacity of this thing, and I have enough juice left for the 3rd night easily. All right, so that's the setup, and I'll let you know how the 3rd night goes. So last night was the final night of imaging. I shot for 6 hours, a little over 6.25 hours. So the total of the 3 nights imaging, I ran for 18.5 hours, and I used 86% of the capacity of this 100 amp hour Battleborn. So 89.5 amp hours over 3 nights, averaging about 6 hours a night, with a total capacity of 12 volts or more of 105.5 amp hours. So there really was no question that this would work. I mean, it's a battery. Obviously, it's going to work and supply power. The question is, how easy is it to use? It's relatively lightweight, weighs less than half what a 100 amp hour lead acid battery or AGM battery weighs, and you get the full capacity of these things. And as I said, it lasted for the 3 nights. It had extra juice, which would bring it to about 21.5 hours. So it depends on how many hours a night you image, how long this will last. The other thing to mention, remind you, is that I used an average of 63 watts on this rig each night. So that gives you some idea relative to your load, how long that would take. So hopefully this helped you to understand how well the Battleborn will work for you and what size battery you need, even if you don't buy a Battleborn. I'll ask you to like this video, and you can subscribe if you want to see some more videos like this. And don't forget, I have a website, californiaskies.com, where you can find more things on astronomy and astronomy equipment. Thank you for watching.